Hello, everyone. I'm Shai Almog, and I love Java. Hopefully, you do too. It's been like a 30-year relationship practically by now with Java. And, you know, I still love it, even though it's been 30 years. But occasionally, you know, after that long of a relationship, you kind of start checking out Kotlin or Scala. And, you know, they have some nice features on them. And you're starting to think, maybe, you know, there's something there that you might be looking for beyond your relationship with Java. Well, this talk today is about bringing back some of that love to Java and some of those features that it's missing from those other languages, and much, much more than that, into the core Java. And if you, like me, love Java, then this talk is for you. So before I begin, let's talk a bit about me. One of my favorite subjects, obviously. I've been building programming for ages, practically. But one of the biggest things I'm known for probably is my work at Sun Microsystems and Oracle, and that's probably the most relevant to what I'm doing here, what I'm talking about today. I also have a website, debugagent.com, where everything I'm going to talk about today is discussed. I also wrote a couple of books, which are supposed to pass around here if you care to take a look. I had actually 4 of them here, but someone had a bit of sticky fingers earlier on, so there's only 3 copies now. If someone wants to bring it back, that's what I'm saying. It would be nice. Anyway, moving on. You know, my favorite thing about Java is that Java is conservative. It's something that's really great because I'm building all of these things on top of it. And it's important when you're building things in the air that the base level is still stable and reliable. And conservative also means it's a bit slow to update. As we saw today, it's a bit improved in that regard. So we have all sorts of weird switch cases and stuff like that was added to Java 21. Yippee. When you're looking at the stuff that's available in Kotlin and in other languages, it's kind of, well, yeah, it's improved, but not too much. But it gets a bit worse. I'm sure pretty much everyone here is familiar with this meme. Great, we have Java 21, yippee. Most of us don't get to use it. We're still stuck in Java 8, or even worse in some cases. Lots of the people that I see that have hate towards Java have it because they used Java 1.4 and project it on what we have right now. So the example of string templates, great, we have it as a preview in Java 21, but we can't really use it. It's such a useful feature and such a basic feature, but we still can't make use of it, even now. And that's where Manifold comes in. Manifold lets us build all of those things, use all these great features, and much, much more on current Java, on Java 8, and get much more from Java 21, stuff that I'd say even Kotlin can't dream of in some cases. And I know that's a tall order. I'm going to deliver, and I think lots of the stuff I'm going to talk about might be too quick because it's a short presentation. So check out my website where there's 4 videos covering everything. So Manifold is an open source extension to the Java language and compiler. That means it sits on top of the compiler and adds language features to Java. And it does that while still being conservative. That means it doesn't break the concepts of Java. That favorite thing of mine in Java, Manifold is still very, very conservative. Now, that sounds insane. You know, you're changing the language. How can you be conservative? Well, to me, conservative means not cheating when it comes to Java. Not doing things like invoke dynamic, if someone's familiar with that. That's cheating. That's using a bytecode that's overly creative and overly problematic if you want to do native compilation and stuff like that. Manifold doesn't do that. Manifold compiles stuff statically, and if you're using code that it generates outside of Manifold, it will still work. It won't break. And the way it works is it's got 3 parts. The first is an IDE plugin that you need to install into the IDE. The second is a plugin for Gradle or Maven, which you need to add into your PALM file, into your Gradle file appropriately. And the last one is the set of Manifold extensions. Now, this is the nice part about Manifold. The extensions are very dynamic. That means you can take the features of Manifold that you want and only add them. You want this specific feature that I'll demonstrate today, you can only add that. You'd want another one, you can only add that. And it's all very, very generic and dynamic. So it does that by manipulating the bytecode that is generated by the JVM. And that makes it very compatible. This is kind of similar to the way Kotlin and Scala compile stuff to bytecode. And that way they're partially compatible to Java. But it's not quite the same, because when we make a leap to a different language, we change more things. So it's a bigger leap than it would be to just move to something like Manifold. But if you really love Kotlin, then move to Kotlin. It's a great language. It's wonderful. If you love Scala, move to Scala. If you want to take some of the features and go a bit further, then Manifold is better. The flip side is obviously the fear of compatibility. When I give this talk, the most popular language is, will it be compatible? Yes, because it compiles to bytecode. So it will work exactly the same as any type of bytecode compiler. It will remain compatible for the future to come and should work with anything. Now, some of you might be having associations with what I'm talking with other projects from before, like Lombok. Lombok's great. But it also has some inherent problems. And some of these problems are obviously due to its age. It's an older project than Manifold. And as such, it has advantages. It supports all IDEs. Manifold only supports IntelliJ and derived IDEs. That means it works with Android Studio, IntelliJ IDEA, stuff like that. It doesn't work with VS Code and other tools. But Lombok does. On the other hand, Lombok's architecture is very old and very limited by comparison. It also is much more, it's much simpler as a solution. Lombok is sort of a hack, in a way, to solve the problem of getters and setters. Whereas with Manifold, we have a far larger and complex solution. Because Lombok is so much simpler, it's just getters and setters, we can do an exit from Lombok. We can translate Lombok code to Java code. But with something like Manifold, we can't do that because it's a far more sophisticated tool. It's similar to leaving Scala or Kotlin. You can't really exit it easily. But it is more extensible, and it's has far greater reach than Manifold. So let's go for a demo right here. And this is a relatively simple example where I want to use JSON parsing with parsing and generating with Manifold. Now, most of us do this every day. And we use stuff like Jackson or something else like that. And that's wonderful. That works really, really well. In here, we see a simple JSON file, just a few properties, and a map with some keys. Now, the way that I would normally parse that, I would just create a class file with the attributes and another class file and just read it and parse it and get it over with. But with Manifold, I can take a sample JSON file that I already have, which is what you normally would have if you would read JSON from somewhere. You would just take it from the docs, copy it, and paste it into the resources directory over there, and name it, in this case, test.json. And that's very simple. But what I want to do is, first of all, show you that I don't have a class name test. I don't have anything here. There's nothing up my sleeve or anything like that. I just have a regular single class of an application. And the class test doesn't really exist. So the moment I refresh Maven, what we'll see is that a class name test suddenly appears, even though I never wrote it. Now suddenly I have a class called test. And that class called test can actually already includes pretty much the entire information that existed in that JSON file. In this case, I'm using a builder pattern to create an instance of that JSON object, even though I never wrote the actual code, right? So how does that work? Manifold treats JSON source file as if it's code. So the JSON source file is compiled into a class file, actually into two class files directly in memory with no intermediate Java source file. Let that sink in. JSON code actually became Java source code. And you don't need to generate files to essentially write JSON. You can parse JSON based on example, and it will just work. So your single point of truth, which is one of the most important principles in programming, becomes the actual JSON source code. Now, if I use Control-click on one of those attributes, it will actually go into the JSON source code. Why? Because the JSON source code is the source code. You no longer need a Java class. You can just write JSON. And if I have a schema file, if any one of you ever used a schema in JSON, which very few people do, sadly, then it will be even more accurate. It will support enums, it will support everything. Notice it supports the hierarchy within the JSON. It created the nested hierarchy and everything completely seamlessly for us. That means that if there's a problem, I can just update the JSON file, refresh Maven, and suddenly I can parse additional data seamlessly. Now, the cool thing is that this isn't limited to JSON. This works with XML, this works with CSV. I can read the file as JSON and then write it to XML, even if I didn't give an XML example, because it understands the hierarchy and the structure and created that class file, and it knows to generate XML. It can parse XML that way, it can parse CSV, it can do all of that seamlessly. These are all source files for Manifold that actually understands and is able to read that data. And this is, I haven't ran into something like that in any other language. So I don't think Kotlin has that. I don't think the JCP will ever do something as insane as that, because that's freaking insane. And it's just a fantastic tool. Moving on, because this is just the tip of the iceberg of Manifold. Remember, I started this by saying you won't understand anything I'm saying because it's mind-blowing, okay? So check out my website where there's much more about that, and it's even more insane than what I showed here, but there's lots of other features I want to show. And this, if you've used Lombok, you should be familiar with this code. That's just simple Lombok code, nothing unique, nothing special. This is the Manifold version. Both seem kind of identical, but you'll notice that philosophically, Manifold tries to do the right thing, TM, right? It tries to work in not just do a workaround, but actually write correct code. So the var property works very much like a getter and setter. But notice it doesn't have the private element on the field. With Lombok, if you used this sort of code, then it's kind of weird. You have private fields, but then you invoke a set number method, and that doesn't exist, to sort of modify a property that's private with nothing there. That's kind of weird. Here we don't have a private property. we have a property. This will generate a private field and public setters and getters with exact same thing as Lombok does. But the difference is that when we use it like this. And this code will generate getters and setters. That means if you will decompile this code, you will see that properties.number equals 5 is a set number equal to 5. And we will see that Pojo number equals 5 also does the same thing. Getters also work the same way. It will convert this into getters, and not just in code that uses properties defined by Manifold. It works with all getters and setters in Java. That means the Java.IL calendar has a getInstance method, but when using Manifold, I can use it as a property. If you've used Kotlin, this is very familiar. It will just work the way that it should with getters and setters. And that is a far more correct way to write this sort of code. Moving on, because, again, so much. Anyone here did 3D graphics, vector multiplication, all sorts of stuff like that? If so, then you probably wrote code like this, where you take one vector, another vector, you add that vector to the other vector, and you get a result. Kind of similar, simple stuff, not unique, sucks. Why does it suck? Well, the plus method. You know, you want to write math, you don't want to write plus. Okay? How's about writing it like this? Now, that code is 100% identical in terms of the bytecode to the previous slide. No difference. Why? Because it recognizes the plus sign, it recognizes that the two methods have, two classes have a plus method named plus with the expected parameters and return value, and it generates that. And this works seamlessly with every class that includes the plus. This works even for expressions like this. So you would expect that this would work with a method called greater than or stuff like that. If you would expect that, then you'd be wrong. Because Manifold is kind of built on top of Java, and it tries to think the way that we think. So any guess how this works? Anyone? Comparable. Yeah. So this will work just with comparable seamlessly. So it will do a compare to and return the result, and appropriately will bring greater than or lesser than. Anyone want to guess what would happen in this case? So obviously the right thing to happen in this case is pointer comparison, and that would still happen. No, don't worry, they won't break Java. Okay? No worries. But they can. And they do. Sort of. The way it works is that you can implement an interface in the object to indicate if you actually want to keep the default behavior of the equals operator. By default, it will obviously do a pointer comparison because that's what we all expect. But you can override that to invoke the equals method, to use the compare to method, to use all sorts of other heuristics that you might choose, sort of weird heuristics. And that's pretty cool. But the coolest thing is this. I'll let that sink in for a second. And for those of you who didn't get that, this is a map. And here I'm looking within a map using the array operator, but it isn't an array, it's a map, and it translates to map.get with that value. And the same thing, the assignment into the array is map.put with the key within the brackets. Like in Python, this looks like Python code, but it's actually good code, not Python code. Right? It includes the type safety, it includes all of the stuff we have in Java without all the, oh, it's Python. Right? That's wonderful. So, but this goes much further, because as I said, and I'm not kidding, Manifold is insane. Okay? So, I won't talk about the force equation below because, frankly, I suck at physics completely, and Newtons and everything, don't get me started. But the top one is really simple, even for an idiot like me. So we've got speed, miles per hour. You can actually use units on values. I can take a variable or a constant, in the case here of 3 hours. I can take the speed, say it's in miles per hour, then multiply that by 3 hours, and the result is the distance, it's the length. That's an equation that is familiar to all of us. We can read it and it's obvious, it's familiar, and it compiles under Manifold, which is the really weird and insane part. It compiles. What the hell is going on there? It sounds insane. What's happening? Well, what's happening is that Manifold has support for units and lots of types of units under the hood. It's everything, as you can see here, from length units, kilometers, millimeters, milliseconds, time, volumetric, you name it. There's everything here, except for currencies, surprisingly. Someone wants to wager why we don't have currencies here. Exchange rates, yeah. Exchange rates, it's just, apparently money is more complicated than physics, who knew, right? So it works through an interface for temporal units, and for units in general. And it knows how to convert between different types of units. And the way it works there is that when you give that secondary argument, it converts it to a type of unit, and then it does operator multiplication between these two units in that particular case. So in this particular case, the velocity temporal class, the velocity unit, had a method like this, which is times. Times is the multiply operator. And it accepted a time argument. So the first argument was converted to a velocity object. Then it saw that there's an operator for star, and it invoked the times method, which accepts a time as an object. The second parameter was a time, 3HRS, was converted to a time. I could have made it into 3 seconds, I could have made it into 3 days, and it would work and would compile. And then it just creates a length value. And as you saw, there's a lot of pre-existing units that work with practically everything. And you can just calculate pretty much every insane thing that you might think. So the next thing, we talked about string templates today. And we saw the weird Java syntax, which I actually like. You know, I'm for that weird syntax. You know, it's wonderful, that Java 21 weird syntax, when it actually lands. But Manifold couldn't wait for that, and they wrote this code way before Java announced the actual syntax that they were going to use. And this code uses the syntax that we all thought Java would add, which is the $ syntax. And it's available now in Java 8 with Manifold, and will be compatible forever because it's part of Manifold, and it's just compiled to bytecode. So for JVM, it will look exactly the same. So you don't need to update to Java 21, actually, whatever LTS it will be where it finally lands, to get this kind of basic feature in Java. And as I said, because this is all integrated into the IDE, doing a control click on world would jump to the world. Doing find usage will work and show it inside the strings. It all works as you'd expect. /$world would print $world, just like you would expect. Everything behaves exactly like you would expect, and would translate to just standard bytecode, so will work forever. But this is kind of the simpler version. You know, Manifold always has to go the extra mile and make something really insane out of it if you haven't got it by now. And the thing that it has here is templates. Now, a template is a file that you can just place in the templates directory. And as you see, it accepts parameters. And I'll put in a title and a body parameter. And then I can use them within the template, like you would pretty much in JSP. But more so, I can actually write code within that file, just like you can in a JSP file. Because this, if you haven't got it by now, will translate into a class that we can use in runtime. And in runtime, I can just, in the code, I can invoke a render method that accepts these two parameters with their types and everything, and it's all typesafe and everything. And this will render this template. Now, the use cases here are fantastic. It's not just web, it's not just, this is essentially JSP or ThymeLeaf built into the language, and far more efficient because it's kind of small, it's just Java, so it's just a Java class, it's not too big. And it's far more efficient and far more powerful, because think about every email you need to generate to send to users. Think about source code generation, which is what I use this for. Think about all of the cases where you need to generate a complex string with complex logic. This is far simpler than pretty much every other thing similar to that I've tried. And it's just so easy to use. This is a standard stream method. Nothing complex. Notice the stream call here. It sucks. Let's remove it. Okay? Everyone here hates stream method. You know, I hate it. It's redundant. Why do we have it? We have it there because the people at Oracle hate us. That's the only reason. They want us to type another method name. It's about verbosity. Java is so verbose. Why do we need it? Well, obviously there's a reason. They can't remove it because they can't add all of these methods into the collection class. They can't. They can't do that. We can. And the way we can do that is through extension methods. And extension methods work by adding a method into a class that is in a package based on a class name. So in this case, Java.util.collection needs to be part of the package name. Part, so your package can't start with the word Java, obviously, but everything else can. And then we just place an arbitrary class there, mark it as extension, and then we just write the method in there. And this method will be added, sort of seem like it's added, into the collection class. And the way that works is the compiler notices extension methods and essentially just invokes the static method, right? It's not great magic, you know, it's actually really, really simple. The compiler cheats us and invokes this method instead of calling that actual real method. And that works kind of simply. Notice that the first parameter is this, right? So this parameter is what we need to use. Notice that the code uses t instead of this. Well, here you go. Java arrays can also have methods injected into them using a special interface of Manifold RT array. And we do that, we can add, it already has all the methods from the arrays class, which we use a lot, but this makes more sense technically. And this works like that, as we saw the array.ext class, and it just has all of these methods. Notice that because it's an array, the first object of this object can't be an array. Anyone want to guess why? So primitive arrays are a problem here, because we can't know if it's a primitive array or an object array, so we can't write it in a generic way. But other than that, it works pretty much like every extension, and we can actually add new methods, the first methods, into arrays. So, and the final feature I'm going to talk about today is something a bit, well, you know how we cheat sometimes with reflection? You know, we want to go and invoke something that we shouldn't normally do, but we need to. And, you know, I have a confession to make. You know, I'm Shai and I accessed a private field. Sorry, I know, yeah. We all do it. You know, we don't want to, but we need to. Sometimes you need something to work. And that sucks, because you write that reflection code, you forget it ever existed, you compile the code, and then you go away. And then, a few years later, some poor sap is working with your project, and suddenly it stopped working in VM such and such. He installs that VM, code still compiles, but fails in runtime. Sucks. Why is that? Because reflection code doesn't have compiler checks, obviously. This essentially removes the compiler checks on things like private access and scopes. And the way it works is it uses reflection under the hood. It generates reflection code. But before it generates that reflection code, it tests that that reflection code actually works and compiles. So it actually changes the value of a string, obviously something you should never do. But it works and it verifies that the field is there. If a future version of Java would suddenly rename the value field, this code will stop compiling. So it's the exact same thing as if I wrote reflection code, but in this case, it will actually fail during the compile stage and not in the too late stage when it's actually in runtime. So it makes something that's shitty a bit not as bad. So I think it's a great feature in that sense. If you have to use it, don't use it. But if you do, well, don't. But maybe, I don't know. So I didn't measure the time correctly, because I do have a bit more time for another feature, but I thought I wouldn't. So I don't have time, I don't have slides for graphical, but Manifold has support for graphical, which is, if you've worked with that, sort of alternative to REST. That sucks, in my opinion, but people use it and like it. One of the things about graphical is that it really doesn't work well with Java. But with Manifold, it knows how to read the schema file from graphical and provide essentially something very seamless, similar to the stuff we saw with JSON. And that's pretty fantastic. It also includes this abomination. If people from C and everything, you know, but sometimes you need it. So it exists. I won't speak the name. Yeah, not too many C programmers here, I guess. Okay, yeah, it's a pain. You live with it every day. It also includes support for JavaScript. Now, you know Java includes support for JavaScript inside of it already. That's not something new. But it isn't really accessible. So if you want to invoke a JavaScript function, you have to load the JavaScript interpreter, run that function, etc., etc. It sort of includes it as a first order language, and you just invoke the JavaScript function and it just works. Kind of nice. Also, one of the latest features that came out relatively recently, so I didn't have slides or tutorial about it, is native SQL support, which means it actually treats SQL at the level of treating JSON and stuff like that. So with that, I hope you enjoyed my talk. If you have any questions, obviously I'm happy to answer, and all of that stuff is available in my website with a lot more detail. So thank you all, and I hope I didn't keep you too long from lunch.